Jordan, I've started the recording, just so you know, and we'll get started in one more minute, everybody.
Okay.
All right, everybody, we'll go ahead and get started with today's NCLUG Tech Talk. I hope everybody had a nice long holiday break, and now we can get back to some CAD business. So today, Tech Talk is going to be what's new in drainage and utilities. But first, just go over our housekeeping rules. This is going to be recorded, and we'll share the event posted on our website after this event. NCLUG is offering PDH credits to those who have registered on the website for this event. And after the session, NCLUG will send out PDH credits to those who have attended. As of right now, I know we owe y'all some PDH credits for some of the past events, but I think Ian is working on those now, and they should be sent out soon. And then stay tuned till the end, where we'll be holding a drawing for a $50 gift card. And so now I'd like to just turn it over to our presenter today from Bentley, Jordan Hatfield. Thanks, Jordan, for joining us.
Thanks, Patty. So welcome and thank you for joining me today. Like Patty said, my name's Jordan Hatfield, and over the next hour, I'm going to share with you what's new in the newest release of Open Roads Drainage and Utility. So you might hear me refer to it as 2020 Release 3 or maybe 10.9. All right, so here's an overview of all the enhancements that have been added into the 10.9 release of Open Roads Drainage and Utilities. So I'll just kind of step through each one of these enhancements one at a time. So we'll start at the top. We're going to go over the move from Open Flows 10.2 to 10.3. So the civil products in 10.8 were way out of date in terms of Open Flows versions. In 10.8, they were using the 10.02, and the current version of Open Flows was 10.03. So that second set of digits is really what's important there. From going from 2 to 3, that's a full schema change. Having an Open Flow schema change is in fact a civil schema change because the DGN is not backwards compatible, meaning that you can't open up a DGN that is in a head schema in a back schema. So in 10.9, we have gotten with the most current version of Open Flows, and we're now using 10.3. Now, I believe there is a new release for Open Flows about the same time that 10.9 released, but they're schema compatible. They're both in schema 3, so there shouldn't be any issues there. And here I have just a screenshot of the About ORD Drainage and Utilities dialog. And you can use this dialog just to kind of see what version of Open Flows that the civil product's currently running. So here at the bottom of the screen, or the bottom of the dialog, you can see that the 10.3.01.08 is what's being used in this 10.9 version. All right, so next, this is not really going to be applicable to you all, but I have one slide in here just to quickly, let you be aware that it was added. So for the rainfall, United Kingdom Flood Estimation Handbook, 2013, we had existing support for this, but it was for the 1999 version of the rainfall data. And now we have the full support for the most current version, which would be the Flood Estimation Handbook 2013 rainfall data. All right. So this next one, so if you've used Model Builder in the past, you've probably seen this message. So in the past releases, we have not included this component in the install. And what we found is a lot of users do not have permissions to install databases to their machine on their own. They usually have to get an admin to do it for them. So in 10.9, we've included this component in the actual install, so you shouldn't see this error message anymore. All right, this next one is just like a user interface change, not a really big change. But what I have highlighted there where it says options, it used to be a green little tick box there, and it was called Project Defaults button. And we've replaced that with the options button. And as you can see, it's separated into two different options. We've got the drainage options and then the utility options. So what this allows you to do is manage the settings for the two databases separately and set up at the same time. All right. So in 10.8, this is kind of a biggie. There's not a lot on the slide, but it is a big item. So in 10.8, when you were to change a feature definition, it was really only changing the feature symbology. So it was not updating any of the hydraulic properties of the feature. So the actual prototype that was assigned to that particular feature definition was not being updated when you changed the feature definition. So this has been fixed in 10.9. So now in 10.9, when you do change a feature definition after placement, the new prototype of that feature definition will be read and applied. But when you do make these changes, you just need to be aware that it has to be for the same type of element. So for instance, you're not going to be able to switch between an inlet and a manhole. It would need to be between, two of the same type of element. Okay, the two scenario flex table. So flex tables are like spreadsheets. It's like a spreadsheet view of your data. So typically you can only see one element type at a time in a flex table. So you might have a flex table for a conduit or one for a catch basin. There's a couple flex tables that we have that kind of combine them and you can see them both. Like I think there's one for a conduit and catch basin. But typically you can just see one element type and also just one scenario. In 10.9, they've added the ability to create a flex table based off of two scenarios. So there on the left, you kind of see the process of how you would get to this option. So in your flex tables dialog, you could right click your table and add a new two scenario flex table. And then it'll bring up this dialog, and the first scenario is going to be grayed out. So it's going to go ahead and just use whatever scenario you have active in that moment for scenario 1. And then in scenario 2, you're going to have a drop-down list where you can choose what scenario you want to compare scenario 1 to. And I've just included this screenshot as an example. So you can see I've got pipe 1 kind of duplicated on these first two lines. So that's how they're being compared. So I have maybe the diameter here for scenario 1 versus scenario 2, the flow for scenario 1, scenario 2, and so on. Okay, and the critical storm wizard is next. So prior to 10.9, if you wanted to run unsteady state analysis and do time varying simulations, you would have to first go through and create a large number of scenarios prior to running the calculations in simulation. So with this new critical storm analysis wizard, it's going to give you the ability to easily run a large number of storm events on a system and identify the worst case scenario, the worst case storm for every conduit or node without having to create your scenarios up front. So this is going to be located in the analysis ribbon under the compute button. I've got shown there in red, the critical storm analysis wizard. So like I said, when you're going to do this, instead of having to manually generate all the different scenarios, which is going to take you a lot of time and then also leaves a lot of room for error, the front end of the process is now going to be automated based on 2 or 3 steps in a wizard. So I'm just going to go through the steps that you would see in your wizard. So this would be the first dialog that you would see, where you would select your base scenario. So this is going to be the scenario that all of the other scenarios are going to be based off of. So it's going to use all of your other alternatives that you might have, with just the exception of maybe your storm data that's going to change, or your calculation option, depending on what you choose in your wizard. So you would select your base scenario, and then you could select your analysis type. So maybe like the hydraulic graded nodes or the flow and conduits. And then once you select these, you would select next, and then it would bring up the next dialog in the wizard, which is going to have you select your IDF storm group up here. And then you have got your return periods, which there's also a column for climate change that you can add. And then you could select your duration. So you basically just kind of toggle in here, and you can see how easily this amount of permutations can build, and there'll be a lot of scenarios that might need to be created. So by doing it this way, it's a lot quicker. Then you would just select next. And then the third dialog will allow you to specify a storm event profile library or profile that you might have in an XML file to generate the different events and the scenarios. You can select a hydrology prototype to define how runoff is calculated. You've got some calculation options where you can define the calculation duration or output interval. And then that's the last step in the wizard, and the last screen that'll come up is just going to be a preview of all the scenarios that are going to be created for you. So once you select finish here, you can go back at this point. If you want to make any changes, you can hit the back button and modify it from there. But once you hit finish, a scenario is going to go down through the list, and it's going to create each scenario, load up the relative data, run the calculations, and then that process is just going to be repeated over and over again quickly for each one of the scenarios chosen in the wizard. So once these scenarios have been created, loaded, and calculated, then the results are going to be combined and organized inside of this critical storm summary that I'm showing now. So what this is going to do is going to show you the scenarios that are going to cause the worst case. This is going to be dependent on the analysis setting that you chose. So if you had chosen hydraulic grade line at nodes, or maybe the flow and conduits, this would be different. But these scenarios aren't actually scenarios yet, so they're not taking up any disk space. But what you can do, you basically would go through your list, and you would pick the scenarios that are of interest to you, probably the most critical, and you can select those scenarios and export them from the list that was created by the wizard. And just those scenarios will be exported, and then you can use those to run any type of further analysis or comparisons. All right, new tool's been added for place nodes at interval along alignment. So this tool is called Place Nodes, and it is a new button that's been added on the Layout tab right next to Place Node. So this tool is going to give you the ability to place nodes at a specified interval along a linear element. So if we take a look over here on the right side of the screen, look at the tool setting dialogs. The first thing you're going to see is the reference element. So when you go to use this tool, you're going to select your reference element, which is probably your center line of your roadway, maybe your gutter line, wherever you want to place the nodes along. And then you would set your elevation, which could be, you could type in an elevation, or you could choose an elevation reference, like from a surface. You would specify the interval, the station range, and the offset. And what this does, it's going to rule each node to that linear element. And it's going to be as if you use Civil AccuDraw station offset to place them. But since they're not ruled as a group, they're still ruled individually, you can place them at a certain station offset and then go back after placement and go into the properties or the text manipulators for those nodes and make changes to the station offset or elevation values then. So going down this dialog, the next thing we have is the relative rotation. So you would set the rotation of the nodes, and that's going to be relative to the linear element. And then below that, we have an option to create conduits in between the nodes that are placed. So when you have this toggled on, you can then select a feature definition to be used for those conduits. Right here, you can even put in, your prefix for how those are going to be named. And of course, your feature definition for the nodes that you're placing. All right, so these next two I'm kind of lumping together. They're both included in the Place Node tool, and they both enhancing the Place Node tool. So the first one is the elevation is invert property. So in 10.8, when you placed a node, the elevation of the reference element was always assumed to just be the ground elevation. This always worked fine for like inlets and manholes, but you may not want to use that when you're trying to model a proposed ditch or maybe an existing water course. In these cases, you would want the ability to state that the elevation reference represents the invert elevation and not really the ground level. So you've added this toggle here on the Place Node dialog where you can specify that. So in the case that you already have a ditch modeled as part of like a road corridor, for example, or maybe it was surveyed and it's just an existing water course and it's inside of your terrain model, then the reference surface that is selected is reflecting the ditch bottom, and the elevation you're actually going to be getting from the surface is the invert elevation. So when you use this toggle, you're still going to have the ability to specify a vertical offset. And then you can also you have the same capabilities as you would before as far as elevation goes. So you could type in an elevation or use an elevation reference. You probably wouldn't want to use this toggle for like manholes or inlets, but you would want to in the case of head walls, outfalls, and cross sections. So we'll get into cross sections a little bit deeper in the next slide. So I'll just go on to that. So cross sections are used in conjunction with channels. So when we think of a conduit feature definition, you usually think of like a pipe or a culvert, but conduits can also be open channels. So when we want to model an open channel, we can use a conduit, and that's just going to be a uniform cross section that's extruded along a center line or an alignment. But if you have a situation where you're trying to model a ditch or a water course that has varying cross sections, then you would want to use a channel instead. So what a channel element does, it doesn't have a shape or a size because it's going to be, those features are going to be inherited from the start and stop nodes, which are cross sections. So these cross section start and stop nodes are placed along a channel to define the cross-sectional attributes of the channel, being placed where you have changes. And then you would follow back through and place channels in between those cross-section nodes, and then the channel would simply just transition linearly between each cross-section. So cross-sections aren't really new, but what we have added is the cross-section from surface. So if your surface includes a ditch or channel, then its shape might not be constant between the nodes. It could be constant between the nodes, or it could be irregular in cross-section in the case that it's an existing water course, or maybe you have a ditch modeled from the roadway template, and it might have point controls applied to it to control the ditch bottom widths or side slopes. So if this is the case and the shape is changing at each cross-section, then it's probably not practical to create a 3D cell for each instance. So instead, we can use this new cross-section from surface tool to extract an irregular cross-section from the elevation reference. So in this image I have here, if we start in the middle, this is just showing a cross-section node that's being placed along an existing water course. In the properties that are being shown here on the left, right here where it says irregular channel cross-section, we have a collection of 6 items. So I've opened that up over here on the right, and these 6 items are just a collection of station and elevations. So it's calling these stations. It's more of like HECRAS terminology, where the station's really going left to right of the center line. But you can see how this is going to model that particular cross-section from the surface. All right, so in this particular case, I think a video is going to describe this a lot more. These 2 fixes that are for place node are primarily for like rural type of drainage. So I'm going to play this video next, and I think it'll do a better job of explaining what these tools can do. I think you'll find they're very powerful.
I've referenced in a terrain model for a survey. This ground and road, and you can see how the contours bunch as an existing water course has been picked up as well. And we can see this on the right-hand side in the view of the 3D model. Now, I've already placed one head wall. I'm going to place the head wall at the upstream side of the existing culvert. So I'm going to run a place node tool. The feature definition that I want to place is a head wall, so I'll select that. And note in the dialog that I can choose that the elevation that I specify for this node is the invert as opposed to the ground level. So I then follow the prompt sequence. So I'm selecting the reference element for the node elevation. So that's going to define the invert elevation in this case. And then I'm going to snap that node down at the invert of the existing watercourse and rotate it around. So that's now placed, and I might want to link my 2 head walls now with a conduit. So again, from the feature definition, I'll select the conduit that I want to place, perhaps a concrete conduit, a particular diameter for my culvert, maybe 900 millimeters. I can snap to the upstream and the downstream head walls. We then see the conduit built in the 2D and the 3D model. If I select that conduit now and look at its hydraulic properties, there's a setting here, is culvert. Now this could be set by default in my feature definition. In this case it's not, but if I was to toggle that to true, and then when I compute the hydraulics, that conduit and the head walls will be computed as a culvert. Let's continue laying out my conveyance system. So I want to go back to place node again. And before I do that, I'll just go to the Explorer and have a look at my feature definitions. I've got 2 feature definitions here for cross-section nodes. So if we look at the properties of the first one, it's set up as a cross-section, and in this particular case, it's going to be a metre wide. This is a trapezoidal channel, so it's going to be a metre wide, a metre high with side slopes of 1 in 1. If we look at the properties of the other cross-section, the prototype here says cross-section from surface. So if we go and have a look at that prototype, there it is. If we have a look at its properties, the option here is set to from surface, and what that means is when we place the cross section, as you'll see in a moment, we're going to derive its information from the terrain model. So back in place node, I'm going to go and select that cross section. So I'm going to pick from surface, that feature definition. The cross-section from surface category comes into play. There's a maximum offset here of 10 meters either side of the location point. So if I pick my terrain model and then I locate a point in the existing watercourse and set a rotation, I'll just click to place that and maybe place one more while we're here. Absolute rotation again and just align it to the watercourse there. If we now have a look in our 3D model, we can see the cross-section here faithfully represents the terrain model. If we go and select that node in the 2D model and we look at its utility properties, we can see that there is a collection of data. If I browse to view that collection, you can see that we've picked up the points in the terrain model and the cross-section view here shows that resulting shape. And we'll see the same if we view the collection of points for the other cross-section. Now I might then want to go and place a regular cross-sectional shape. So I will pick the feature definition for that. Cross-section from surface grays out because we're going to place a trapezoidal cross-section now. So I could maybe come down further here and maybe place it somewhere here. So again, I'll select the terrain model and set the rotation. And if we have a look in our 3D model now, we can see that we've placed that trapezoidal cross-section shape. So if I was to then place a conduit between that last cross-section and the head wall, I could go to the channels, maybe channel concrete, pick the right shape. Let's go to channel grass, and then we can pick the right shape, and then we can specify our start node and the stop node being the upstream face of the conduit, and there we see the channel built. So we can inspect the model now in 2D and 3D and see how things line up. We can see here that that conduit is being placed such that its invert elevation is relative to the ground model.
All right, so next we'll get into for the batch pipe split. So this tool has been added to the Tools tab, shown here, batch pipe split. And then what it will do, it will go in and look at nodes within a specified distance of pipes or maybe within a selection set. And it will split the pipes at those nodes and then connect those new pipe sections to that node. And then I just have a dialog here showing the pipe batch pipe split dialog that appears when you select this. All right, so on this next item, so you're probably not going to use this very often, but in rare cases, it is possible to create a situation where the conduits have missing nodes, either at the beginning or the end of that link. So in 10.8, we used a key in to find those missing nodes that you see there. It's open links, missing nodes dialog. And then in 10.9, we've just added a button to the tools ribbon. It's called Find Missing Nodes. So when you select this, it's going to go through your model and it's going to look for any links that do not have a start or end node and then list them there in the dialog for you. And then you can go through and select the ones that you want to delete and then delete them. All right, so this next one, we've got a couple properties that have been added to the nodes for feature definitions. So there's two additional properties that have been added for these. They're shown here in this red box. We've got the largest connected conduit size and the smallest connected conduit size. So we can run a query utilizing these added properties to search for the nodes in the design that don't conform to the standards. So in other words, we're we have a way now to look for pipes that are too large or too small for a particular structure size. So I've included on this slide just like a screenshot of a standard detail of an inlet. And on that standard detail, there's a table specifying what the maximum pipe diameter is for certain inlet sizes. So that's really what we're doing here is we would run the query to search for nodes that have pipes that are either too large or too small. And then what that will do with the query, it will create a selection set for us. And from that selection set, we can create a flex table. So again, the flex table is kind of like a spreadsheet view. So it's going to bring up a list of all the nodes that are going to need modified in order to meet our standard. And then you can pretty easily, by using that list, go through and change the feature definition of those nodes accordingly. All right, so we got civil rules that are displayed in the utility properties as read-only. There's two sets of properties available for drainage elements. So we've got the regular civil, element properties dialog, and then we also have this hydraulic utilities properties dialog, sometimes referred to as the open flows properties. So some of the civil properties have been added to this open flows properties as text fields. Examples of these fields might be feature definitions or civil rules. So in the screenshot that I have here on the right, we've got some of the civil rules that are being referenced into this dialog. You can see for like the baseline feature, the station offset values, and the elevation reference. So this isn't new. We've been adding these all along, but we found that users were getting confused about where they could edit these properties, whether it be in an open flows dialog or maybe in the civil properties. So to clear the confusion, in 10.9, they've made the properties grayed out in this hydraulic and utility properties dialog. You can see how they're grayed out here, showing you that those are just read-only. So, and then over here on the flex tables, you can also edit things in the flex tables, but they've added a yellow background to the cells that are not, you can't modify. So over here, they're grayed out in the properties, and then in the flex tables, you're going to see a yellow background to let you know that those cannot be changed. Okay, and just kind of an extension of this. So you were able to edit invert elevations of head walls before. Now it's just a little bit more user-friendly and easier. So for head walls, the height of the head wall is static, so it's not going to vary or change, and it's going to come from the cell. So it's not going to vary like a head, like a manhole or a catch basin would, where you have a bottom cell and a top cell, and the bottom cell is going to extrude up to the top cell, and you have kind of a varying height when you're doing like manholes and catch basins. So we just have a standard height here for head walls. So if you make a change to the invert elevation offset of a head wall, what we're going to do is go ahead and change the vertical offset in the ground elevation to honor that height of the head wall. So what I'm showing here in this slide is on the left, we've got a node that's selected, and this is the invert elevation and set a vertical offset of 0. And then we've gone in and we've changed the invert elevation and just kind of showing how that will automatically change the vertical offset for you to honor the height of that cell. And then that vertical offset is, you can manipulate that as well right here. And when you manipulate that, then it's going to in turn change your invert elevation for you. So one property is going to be dependent on the other. And then when you make any changes in this dialog, the product's going to automatically synchronize these changes within the hydraulic and utility properties that uses those values for calculations. So. Okay, so next we'll go over the Place Civil Profile Name Boundary tool. They've added a toggle for whole conduits only. So Here on the right side of the screen, we just have the place name boundary civil profile tool. And then towards the bottom of that dialog, there has been a toggle that's been added called whole conduits only. So this option's been added, and what it will do is it'll just show a whole conduit on each sheet when placing the civil profile name boundary. So what it's going to do, it's going to automatically cut your sheets at the stop of each last structure that a full conduit can fit on. So we're no longer going to have a partial conduit on a sheet if you have that toggled on. And what this is going to mean, it's going to place an overlap at that structure so that you're going to see that structure on both sheets. And here I just have a screenshot of a profile model where some name boundaries have been placed with that toggle on, or it's just showing where those sheets are going to overlap at the structures. So you're going to see those structures on each sheet. And then each sheet will have a full-length conduit on it. You won't have any partial conduits at the end of a sheet. All right, this next one, this next enhancement is pretty useful. So it's called, it's where you can display the open flow slope in the profile model. So in 10.9, you have the ability to choose which slope you want to display in your profile model. And this is changed in the backstage. So if you hit the blue file button, that's going to be take you to what we call the backstage. And that's where you're going to access your user preferences dialog. Once you're in the user preferences, down towards the bottom, there's a view options civil. And then there is a drainage and utilities section here. At the very bottom, we've added the setting show open flow's calculated slope. Now, by default, this value is set to false, but I've got it set to true here. And then at the top image here, this is showing you what it would look like if it was set to false. So this would be probably the default conditions where you're going to notice that the slope in your profile model is not going to match the slope in your properties. And that's because the slope in the profile model is using the civil slope, which is measured between the connection regions of the cells. So it's going from the inside wall of the vault of the structures. Whereas the slope that's calculated in the properties over here, what we refer to as the open flow slope, that's going to be measured from center to structure. And that's why you have a little bit different value for that slope. So if you set this to true, then you're going to see something more, what we see here on the bottom image, where the slopes are going to match from the model to the properties dialog. And you can switch back and forth between these just by changing the toggle here as needed. All right, so next I'll go over the node feature definition properties. They've added a couple properties where it can now read the cross slope from the road. So in 10.8, the road cross slope was read directly from the prototype. So whatever that default value was inside of the prototype, so we got the prototype showing here for an inlet generic curb grade, has a road cross slope of 2%. So that's what, when you place an inlet, that's what it would be reading there, is that road cross slope. In 10.9, however, we've added the option to where you can read the cross slope directly from the road surface instead. So that's shown here on the right side in the properties dialog. So this is set in the feature definition properties of the node, and there are two settings here. The first one is the use road cross slope, which you could set to true or false. And then the second one is the road cross slope offset value. So when you set the first one to true, it'll then allow you to put in an offset value. And this value is just going to be the distance from the location point of the node. So like where you place that node, and then the cross slope that it's being read from. So what you're doing here by putting in an offset value is you're telling it to read this cross slope of the road and not the gutter cross slope. So you want to put in a value that's going to take you beyond your gutter. And then if you do use this option where you set it to true, if you were to move your node, it is going to be dynamic and it's going to keep updating that roadway cross slope for you, depending on where you move it in the project. So you could have been in a normal section before where this 2% cross slope was okay, but then maybe you moved your catch basin up a little bit and now it's in a super elevated section. That's when having this setting over here is going to be helpful for you to more accurately calculate the inlet capacity. So that cross slope's being used in the Hackcrass formulas to calculate that, and that means if you move your inlet, you need that cross slope to update so that you can compute and check the capacity and spread widths and things like that. Moving on along, so we've got the how the databases are loaded from a reference file. So previously in 10.8, they did add the ability to annotate SU and SUDA data in a reference file. So there's two databases, and they're typically referred to as SU and SUDA, or maybe utilities and drainage. But they're zipped up and they're embedded in a drainage and utilities design file. So when you reference in a drainage and utilities file, there's going to be two potential sources of information that can be used for annotation. Now, in order to annotate SU or SUDA data from a reference file, this really wasn't a straightforward process in 10.8. You had to first reference in the file, and then you would have to create a utility project within that active DGN by using any of the layout tools, like a place node tool would generate that prompt to where you could create a database. Then you would have to close the software, reopen the product, and then at that point, when you reopen that file, then the product will be able to see that there is reference data in there and they do have databases, and then you would be able to annotate that information. So in 10.9, this process has been greatly improved. So now the drainage and utilities reference file is going to be handled the same way that any other reference file is handled, in that if a design file was referenced, then the annotation workflow can see that data and it'll be able to read it, annotate it without any extra workflows. So this is accomplished by giving the option to fully load the two databases when the file is referenced. So at the time of referencing, you'll be given the prompt. It'll ask you if you want to load those databases into your active file. And if you select yes, it'll load those databases, and then you'll be able to view the properties for your drainage and utilities. You'll also be able to annotate any of them, but you won't be able to make edits. So even though the databases are live in the file, they're still references and they'll be read-only. So one thing I want to caution you, so when you load in a database to a file, that's not undoable. So once you put it in there, it's always going to remain in there, and it's going to have to load up every time you open a file. So what I would recommend, if you are going to be loading in databases for like drainage and utility files into your file for like maybe the purpose of annotation, I would create a separate annotation file for you to keep that in, so that you're not loading those databases every time you open up a roadway file. Instead, it's just going to be local to that one particular annotation file that you need it for. All right, and lastly, we have an enhancement to the model builder. So in 10.9, you can specify the external source that the node what the node rotation is for placement of the structure. So you can see a screenshot of the model builder wizard, and then on the right there's an extra column that's been added for node rotation where you can enter in the degrees for that. As opposed to in 10.8, you didn't have this functionality. That functionality really only existed with the subsurface database. But I have here a couple of additional resources that you might find useful. Definitely the Bentley communities. So what I'll do is I'm just going to copy and paste these links into the chat for you all. And that way you can bookmark those. But The Bentley Communities is really helpful because it's going to show you everything that's new, but it also includes a lot of videos. So because of time today, I didn't have a lot of time to show you the different tools. But if you want to go on to Bentley Communities, they've got a few videos demonstrating how to use all the new tools that have been added. And then also here on the right, we've got a link for the ORD Connect Edition help, which also kind of lists out everything that's new. And this is going to give you a list of everything that's new with drainage and utilities, but also with survey and, you know, your regular modeling workflows. But with that, I just want to thank everybody for taking the time to join me today and for your attention. I hope you enjoyed it. You can take with what I've shared today and start applying it to your projects. So I'll place those links in the chat, and then at this point I'll open up the floor if anybody wants to ask any questions. We can have some time for that.
Yeah, so thank you, Jordan. If anybody has a question, you can either raise your hand or unmute yourself, and we'll let Jordan answer your questions. I saw one person had commented, I guess you copied the database. The database. I don't know, I guess.
Right. So if you are like in a roadway file and you want to be able to, you know, annotate your sheets for your drainage information or your utility information, you have to, the product has to be able to see those databases in order to annotate them. So that we can accomplish that, we're actually loading those databases into that file. So that's why I was saying that you wouldn't want to load those databases into like your roadway design file. This would want to be a separate file just for that purpose of annotation or whatever you're using the databases for.
We have a question. Can you have a splitter box with a weir inside of it?
I'm not sure about that. I'll probably have to talk to a colleague and see about that one. So I can follow up on that.
Any other questions? Sure, that was a lot of great information.
Yeah, there's a lot going on in this latest release.
Yeah.
But I think I have this open here. So this is the Bentley Communities page, and like I was saying, there's some links in here on how to use some of these tools that have been added.
Okay.
And I'm not sure if you all have used Bentley Communities in the past, but it's also useful because it has a forum too. So if you ever come into an issue, you can kind of search it here, and typically somebody else has already encountered that issue, and there's, you know, a workflow to get through it. Or
yeah,
I found it helpful quite a bit. And what I've learned, and this is the newest release. So an extra tab has been created here. We now have the help tab. So it's going to have a direct link to Bentley Communities or that help page too.
Okay. Great. All right. Any last questions before we close the session? I'll just remind everybody that we will be sending out the PDH credits soon. And also NCLUG is holding a Toys for Tot campaign. You should have gotten an email about that, but we're just asking for you to support us since we didn't get to host our winter conference where we usually collect toys. We thought it would be a great idea to be able to just still raise money and donate to Toys for Tots. So if you get a chance, please go and donate by December 18th. I think right now we've raised over $1,100 so far, but our goal is 5,000. So we need y'all's support to kind of reach that goal. And also just wanted to mention that we have a special presentation with Lisa Coleman on navigating change. That's going to be December 16th And then also on December 9th, we have a special workspace session. So be sure to join us for that too. And of course, you can find all that at our website at www.nclug.com, and you should be getting emails. So our winner for today's gift card is Kayla Pogus. I probably butchered your name, but congratulations. We'll be getting in touch with you about that gift card. And we are also starting to look to plan some more sessions for 2021. So if you have any suggestions, please email us or feel free to type in this chat box. And let's see, Jordan, there might have been another question, I think, mixed in there.
Yeah, I think it was Linda. She was asking, what if you need additional head wall height? So the head walls are going to be a standard height. So if you had different sizes that you would have, then you would have different feature definitions that would be linked to cells for those different heights. Right now, those really aren't variable. You would just have to have separate feature definitions for the different sizes. In the future, there's talk of using parametric cells that will, you have variables that you can set for different dimensions of the cells that can be variable. But for now, you would have to have just separate cells for each size.
Okay. All right. Well, I appreciate your time, Jordan, and covering this topic for us. We look forward to hosting you again sometime next year, maybe.
Yeah, thank you for having me.
And thank y'all, everybody, for joining, and look forward to seeing y'all next week. Tech Talk.
Thank you. We enjoyed it.